Today we are going to solve some of the problems on unilateral Z transform and its application to solve difference equations. First problem, determine the unilateral Z transform for the sequence x of n is equal to 2, 4, 5, 7, 0, 1. We have unilateral Z transform x of z is equal to summation n is equal to 0 to infinity x of n into z to the power minus n. The given sequence exists for both positive and negative values of n, but unilateral Z transform is defined for only non-negative values of n. Therefore, x of z is equal to x of 0 plus x of 1 into z inverse plus x of 2 into z to the power minus 2 plus x of 3 into z to the power minus 3. So, from the given problem, we have to substitute the values. X of 0 is 5 plus x of 1 is 7 into z inverse, and x of 2 is 0 and x of 3 is 1. So, it is z to the power minus 3, which is the required answer. Next problem, find the unilateral Z transform for the signals first one, x of n is equal to alpha to the power n into e of n. Second one, y of n is equal to x of n minus 2, where x of n is equal to alpha to the power n. We know that unilateral Z transform x of z is equal to summation n is equal to 0 to infinity x of n into z to the power minus n, and it is given x of n is equal to alpha to the power n into e of n. It exists for n greater than or equal to 0. Therefore, x of z is equal to summation n is equal to 0 to infinity alpha to the power n into z to the power minus n, which is equal to summation n is equal to 0 to infinity alpha z inverse to the power n of x of z is equal to 1 divided by 1 minus alpha z inverse. Second one is given x of n is equal to alpha to the power n, then x of z is equal to summation n is equal to 0 to infinity alpha to the power n into z to the power minus n, which is equal to summation n is equal to 0 to infinity alpha z inverse to the power n, which is equal to 1 divided by 1 minus alpha z inverse. And it is given y of n is equal to x of n minus 2, and taking unilateral Z transform on both sides, we get y of z is equal to x of minus 2 plus x of minus 1 into z inverse plus x of minus 2 into x of z. And it is given x of n is equal to alpha to the power n, and then we can write x of minus 2 is equal to alpha to the power minus 2 and x of minus 1 is equal to alpha to the power minus 1. Therefore, y of z is equal to alpha to the power minus 2 plus alpha inverse z inverse plus z to the power minus 2 into 1 divided by 1 minus alpha z inverse, or y of z is equal to z to the power minus 2 divided by 1 minus alpha z inverse plus alpha inverse z inverse plus alpha to the power minus 2. Determine unilateral the transform of x of n is equal to 2 to the power n into u of minus n plus 1 by 4 to the power n into u of n minus 1. It is given x of n is equal to 2 to the power n into u of minus n plus 1 by 4 to the power n into u of n minus 1. Then x of z is equal to summation n is equal to 0 to infinity 2 to the power n into u of minus n plus 1 by 4 to the power n into u of n minus 1 into z to the power minus n, which is equal to summation n is equal to 0 to infinity 2 to the power n into u of minus n into z to the power minus n plus summation n is equal to 0 to infinity 1 by 4 to the power n into u of n minus 1 into z to the power minus n, which is equal to 2 to the power n into z to the power minus n at n is equal to 0 plus summation n is equal to 1 to infinity 1 by 4 z inverse to the power n, which is equal to 1 plus 1 by 4 z inverse divided by 1 minus 1 by 4 z inverse, which is equal to 1 divided by 1 minus 1 by 4 z inverse. Find the natural response of the system described by the difference equation y of n minus 1 by 4 y of n minus 1 minus 1 by 8 y of n minus 2 is equal to x of n plus x of n minus 1, with y of minus 1 is equal to 0 and y of minus 2 is equal to 1. We know that natural response is the response due to initial conditions, that is, we have to make x of n is equal to 0, which is equal to y of n minus 1 by 4 y of n minus 1 minus 1 by 8 y of n minus 2 is equal to 0. Then taking unilateral z transform, we get y of z minus 1 by 4 y of minus 1 plus z inverse into y of z minus 1 by 8 into y of minus 2 plus y of minus 1 into z inverse plus z to the power minus 2 into y of z is equal to 0, or if we take y of z common, 1 minus 1 by 4 z inverse minus 1 by 8 z to the power minus 2 minus 1 by 4 y of minus 1 minus 1 by 8 y of minus 2 plus, not plus, it's minus 1 by 8 y of minus 1 into z inverse, which is equal to 0. Then y of z into 1 minus 1 by 4 z inverse minus 1 by 8 z inverse minus 1 by 4 into 0 minus 1 by 8 into 1 minus 1 by 8 into 0 into z inverse equal to 0, or y of z is equal to 1 by 8 divided by 1 minus 1 by 4 z inverse minus 1 by 8 z to the power minus 2, which is equal to 1 by 8 divided by 1 minus half z inverse into 1 plus 1 by 4 z inverse. Then using partial fraction expansion method, y of z is equal to k1 divided by 1 minus half z inverse plus k2 divided by 1 plus 1 by 4 z inverse, or k1 is equal to 1 minus half z inverse into x of z, y of z at z is equal to half, which is equal to 1 by 8 divided by 1 plus 1 by 4 z inverse at z is equal to half, which is equal to 1 divided by 12, and k2 is equal to 1 plus 1 by 4 z inverse into y of z at z is equal to 1 by 4, which is equal to 1 by 8 divided by 1 plus half z inverse at z is equal to minus 1 by 4, which is equal to 1 divided by 24. Therefore, y of z is equal to 1 by 12 divided by 1 minus half z inverse plus 1 divided by 24 divided by 1 plus 1 by 4 z inverse. Then taking inverse z transform, we get y n of n is equal to 1 by 12 into half to the power n into u of n plus 1 divided by 24 minus 1 by 4 to the power n into u of n. Find the impulse response of the system described by the following difference equation. Y of n plus half y of n minus 1 is equal to 2 into x of n. We know that impulse response is defined for relaxed system, that is for 0 initial conditions. It is given y of n plus half y of n minus 1 is equal to 2 into x of n, and x of n is equal to delta of n, y of n is equal to h of n, and y of minus 1 is equal to 0, that is h of minus 1 is equal to 0. So substituting these values in the given equation, we get h of n plus half h of n minus 1 is equal to 2 into delta of n. taking unilateral Z transform on both sides of above equation, we get h of z plus half into h of minus 1 plus z inverse into h of z is equal to 2, or h of z into 1 plus half z inverse is equal to 2, or h of z is equal to 2 divided by 1 plus half z inverse. Now, taking inverse Z transform, we get h of n is equal to 2 into minus half to the power n into u of n. Determine the step response of the system y of n is equal to alpha into y of n minus 1 plus x of n, where alpha varies between minus 1 to 1, with initial condition y of minus 1 is equal to 1. It is given y of n is equal to alpha into y of n minus 1 plus x of n, or y of n minus alpha into y of n minus 1 is equal to x of n. Now, taking unilateral Z transform on both sides of above equation, we get y of z minus alpha into y of minus 1 plus z inverse into y of z is equal to x of z. And we have y of minus 1 is equal to 1 and x of n is equal to u of n. Therefore, x of z is equal to 1 divided by 1 minus z inverse. Substituting this in equation above equation, we get y of z minus alpha into 1 plus z inverse into y of z is equal to 1 divided by 1 minus z inverse, or y of z into 1 minus alpha z inverse is equal to alpha plus 1 divided by 1 minus z inverse. Therefore, y of z is equal to alpha divided by 1 minus alpha z inverse plus 1 divided by 1 minus alpha z inverse into 1 minus z inverse. Using partial fraction expansion, we get y of z is equal to alpha divided by 1 minus alpha z inverse plus minus alpha divided by 1 minus alpha, whole thing is divided by 1 minus alpha z inverse plus 1 divided by 1 minus alpha, whole thing is divided by 1 minus z inverse, which is equal to minus alpha square divided by 1 minus alpha, whole thing is divided by 1 minus alpha z inverse plus 1 divided by 1 minus alpha, whole thing is divided by 1 minus z inverse. Then, taking inverse Z transform